Hey, this is Doug Rensford with ROI Training. Usually, when you deploy an application, there's an initialization process that has to be run. In this video, you will learn to use a Kubernetes job to set up a database. Let's switch to the demo machine.
Okay, this is the sixth of our 8 videos on deploying Kubernetes applications. Oftentimes, when you're deploying an application, you want to have a program set the application up or initialize the application. And a common thing that you would want to do is create the database and create the tables and then put some initial data into the tables, which is what I want to do inside my Events app. So I created another Node.js program which I have here in this folder, Database Initializer. Now, if we go look at the program itself in server.js, notice here there's a function init database, and up the top of the function, we read in some environment variables that'll allow us to make the database connection, and we're going to create a connection here, and then here we try to connect to the database. Now, when you try to connect to a database, it's either going to work or it isn't. So if it doesn't work, then we would drop into this if statement, and then we would output the message as to why it didn't work. Now, if it does work, then we drop down to the else. And then if you look in the else statement, um, it's pretty straightforward. It connects to the database, or at this point, the database would have been connected to. So we're going to run this command, drop database if exists events DB. So events DB, that's the database we want. But we're initializing or reinitializing it at this point. So we're going to make sure it doesn't exist, and then we're going to create it with this SQL statement here. So we're going to create our database called eventsdb, and then we're going to switch to that database with this command, and then we're going to run this create table query here, which creates our database table. And then lastly, we're going to add one test record. So we're going to run this SQL statement here to insert one record into the database, our pet show record. So if you scroll down, so that's the function that initializes the database for us. Now, if you scroll down to the bottom, that function gets called right here in another program called start. So now all the way down here we're creating a function called start, and then this is what invokes that function. And then here we're in this loop where we're going to continually try to update the database. So what happens is this loop gets started, and then we call init database, which is that function we were just looking at. If it works, then we're setting this variable succeeded equal to true, and the next iteration through the loop, it's saying here, we're going to do this loop while we have not succeeded. So once we do succeed, we're going to drop out of the loop and then exit the function. So now you may be wondering, well, why are you putting yourself in this loop? Well, when I deploy my application to Kubernetes, I'm going to deploy the database, and then I'm going to deploy all my applications at the same time. And this job that I want to start may or may not be ready before the database is ready to take requests. In fact, it's highly likely that the database won't be ready when the job first begins. And I don't know when the database is going to be ready. I'm pretty sure it's going to work and we'll be able to connect to it, but it may not work the first time, right? So what we're doing is we're putting ourselves in this loop, and we're going to keep trying over and over and over again. Now, we don't want to be in a loop that just runs as fast as it can, continually trying to connect to the database. So what's going on inside the loop is every iteration through the loop, at this line of code here, the thread goes to sleep and waits a little while before it tries again. So there's this function up here that is going to sleep for some number of milliseconds that we pass in. So all we're doing is calling the set timeout function in JavaScript, which is just what it does. Put the thread to sleep and wait for that number of milliseconds before you try again. And then there's a design pattern that's commonly used. It's called, the fancy name for it is retries with truncated exponential backoff, right? So meaning what I'm going to do a retry, but I'm not going to do retries as fast as I can. The backoff part means try it the first time, and if it doesn't work, then wait a little while and then try it again. But it's exponential backoff. So if it doesn't work the second time, wait a little bit longer. And if it doesn't work the third time, wait a little bit longer still. And if it doesn't wait the fourth time, wait a little bit longer still, and so on, up to some maximum amount of time that you're willing to wait. So that's the truncated part in truncated exponential backoff. And then wouldn't want the job to run forever if it could never connect to the database. So at some point, we're eventually going to give up. So if you notice the way the loop works, is saying I'm going to loop as long as I have not succeeded, I'm going to continue through the loop. And I'm only going to try 10 times here. So 10 times is the maximum, but then there's a sleep time here. So notice here I'm setting the initial sleep time to 1, which is this variable down here. And then we multiply that by 1,000 because the first time we wait, it's going to be for 1 second or 1,000 milliseconds. So we're going to go to sleep, and then this weird looking command here says, if the sleep time is greater than or equal to 64, then sleep time equals sleep time, meaning don't change it at that point. Otherwise, multiply the sleep time times 2, right? Or double, right? So what will happen is the initial sleep time is 1, and then if it doesn't work, it'll get multiplied by 2, and then so it'll go to 2, and then 4, and then 8, and then 16, and then 32, and then 64. And that's the maximum amount of time we're willing to wait. And then we'll keep waiting from 64 seconds over and over and over again until we hit the maximum number of tries, which is 10. And if it doesn't work after 10, then something else must be wrong and it's never going to work, right? So we can just test this program out right from here and see if it works with my local database. So again, it's just a Node.js program. So if we type node server.js and run it, notice when I ran it against my local database, well, the database is running already. And so on the first try, it connected and dropped the database and switched the database or switched to the database and then created the table and the record, and then it exited out. Now we could simulate what happens if the connection doesn't work. So up here, I'll just I'll just break it on purpose. So here's my password. So if I change that, now the database connection is not going to work. So now we're going to say, we'll just run the program again. So node server.js. And now notice it tried to do the connection. It said, oh, the password was wrong. And then it waited a little while and then it tried again. And then it waited a little bit longer and then it tried again. Then it waited a little bit longer and then it tried again and it waited a little bit longer and so on. So it's going to keep doing this over and over and over again. Now, in this case, it's never going to work because the password is wrong. But when we deploy our application to the Kubernetes cluster, hopefully, well, it's going to work eventually. It's just going to have to wait until the database is ready to take requests, and then it's going to work. Okay. But anyway, so that's how this little initialization program works. I guess in a real app, you would initialize it any way you needed to. You want to get the program in a state where it's ready to run. Now I want to deploy that application with Kubernetes or with all my other Kubernetes microservices. So if we go back here to Kubernetes configurations, remember earlier in an earlier video, we created the deployment and service for the API or the backend API. And then we created a deployment and a service for the web application. Now we need one more YAML file to configure that job, right? So if I click on there, okay, so we can read down through that file. So we're going to create a thing, which is a job. This just gives the job a name. The job has a spec. So the spec configures the pods. So we're going to have a container that runs our events job. So remember, this is our Docker image for that database initializer microservice. And then we have to add our environment variables. So this is just like what we did when we deployed the API. So we have to have the host and the user and the password, which we read from our Kubernetes secret. So that job configuration is pretty simple. So so again, like anytime you just want to deploy something and have it run in the cluster, then you can configure it as a job. And then, the way my program works is once my program is finished, then the program ends. When the program ends, then the job ends, and then the container goes away. Okay. And there's a job, and there's also something similar called a cron job. So my initialization program is a job because it's going to be done once. Maybe I wanted to create another job that I ran, every evening or something like that. Then I could create a cron job, and then I could use cron syntax within the configuration to say, run this program at these intervals. So maybe I might use a cron job to make sure the data within the cluster was backed up correctly or something like that. But anyway, so here's my job that we've configured. Now, at this point, I've deleted everything from the cluster. So if we say kubectl get pods, get pods, then notice there's no resources that have been found. So now I want to deploy my database and my application all at the same time. So I have a shell script that I wrote. So let's go to the automation folder and ls. So we're going to run this shell script here, setup event app.sh. So let's just go look at that real quick. And all that does is it uses Helm to install the database, just like we saw in the last video. And then we apply all of our Kubernetes configurations, which deploy our program along with the job. Now, what's going to happen is the job is going to be ready before the database is going to be ready. And then it's going to be sitting in that loop for a little while, waiting for the job to finish. So let's see. So we'll run that program now. So let's do bash, and then we'll run setup event app. And hopefully that's going to work. So it deployed the database, and then it deployed everything else. So let's run clear. And now we're going to run kubectl get pods -- watch. Now the watch command just says anytime something in here changes, we want to know about it. So notice at this point, the job is running. So that's this guy right here. But the database is not ready yet. Oh, now look, the database just came up. Now it is running and it is ready. And once that database initializer job is probably sitting there sleeping in that loop. But once it wakes up from its sleep, then the job is going to run, and then its status is going to change to completed. So let's just be patient and wait for that. Oh, and there it is. So now the database initializer job has been completed as well. And if we want to, then we'll do Control C. And then if we want to see what happened, we can go look at the logs for this job. So let me just copy the job name to the clipboard, and we'll say kubectl logs, and then the name of that pod. And notice what happened. So the job ran, and the first try, it didn't work, and the connection got refused. And it tried again, and then it tried again, and then it tried again, and then it waited a little longer, and then finally it connected to the database and did the initialization and then exited. So that's pretty good. All right, so we have two more videos left. So stick with me and we'll continue on with more deploying applications to Kubernetes. This is Doug Renstrom with ROI Training.